So, it begins.
Well, hi guys, welcome back, and I hope this is the last part to the repairs of this Yamaha MSX. There's been a long road of issues with this, and I'm just wondering if maybe this has been from the start. There were a couple of errors I did, and one of them you will see will be in this video, and that where the power supply plugs into the MSX, they have a cable that goes from that to a power switch, which then also goes to the cartridge detection on the PCB of the main unit. Unless these are plugged in, you don't get the proper voltages. Don't ask me why. So anyway, that was a faux pas on my part. Sorry, but we all learn. Well, hi guys, I'm just back looking at this MSX again. I've had a couple of parts come in that we think may be wrong with it, but I was just putting it back on the scope to see if I could pick up the crystal oscillations on the boards where it goes out to the video, and that before we go too far into this. And I was checking the two crystals on the little daughter board it has, and one seemed to be okay. And I went to the second one, it was dead. There was nothing there. So I thought, well, that's a bit weird. So I traced it through the capacitor back to an IC that it runs on this little board. So I tried to find the frequency going to the IC from the crystal, and there's nothing. So I thought, well, where's the voltage on it? Is there a voltage getting to it? And I couldn't even find that with the scope. And I thought, well, hang on. So I pulled out the multimeter, and I went to the 5-volt in for the chip, and nothing. So I thought, well, that's a bit weird, because there's actually power that goes from that board to the video board. So I probed along the video board, and I'm getting like 0.2, 0.5s, 1 volt, and it's got to have 12 and 5. So what I've done is I've broken out the multimeter, and I'll just show you what I seem to have found. So I just plugged the power back into the board. That's to the distribution board. Now we'll turn it on. That should be 5 volts. That is ground. That should be 12 volts. That should be minus 12 volts. Now, are you starting to think what I'm thinking? A lot of these issues could be stemming from the power supply. Even though we recapped it, there could be parts in there that are going faulty. So, before we go any further with this, I think we revisit the power supply and see what's going on. So, grab yourself a drink, something to eat, and let's get into it. Okay guys, so I've got this all apart. So what I was going to do is I've taped up this end so it won't short, because this has all the connectors going out to the cable. And then I thought I'll do the same to this end. Then I thought, wow, why not just desolder the two, because it's only a phase and a neutral on here, and put a separate cable on there. I don't have to worry about mucking around with this and twisting it around and breaking the fibres inside. So I've just got the desoldering gun on, so I'm just going to go through and desolder this. So give me a sec. You may see that that's not really desoldering, so what I might do is I might just grab the hot air. This is what I was saying to you guys. If you're having issues with ground planes and neutral planes and things like that that are hard to desolder, this is what you use. Use your hot air. You're just warming the board up. You don't keep it on there. So you're warming the board and the solder up is what you're doing. And you'll smell it. You'll smell it as it gets warm. And then see how, so I'll just put this back and I'll just bring that up to you so you can see it. Sorry, I've got me old jersey on. It's a little bit cool today, so a bit wet and cool. But I'm just trying to see if you can get a picture of that. Now, if it'll focus for you. Now you see how that's pulled all the solder away from those holes? That's what the hot air does for you. So that's what's really, really good with it, with these heavy planes and that. And you can do it with just about a lot of things. And there we have it. So that's out. So now I don't have that in my way. So I'll move that one out of the way. And what I will do is I will grab the other connection I'm going to use and solder that in. Right, so that's got that on, so that's soldered on there now. That's our power LED. That's all insulated. It's all been, I got clear tape over it as well as the black tape around the edges. It's just like, you know, that why they didn't put it on with a plug, I have no idea, because this is just such a big heavy piece of cable. Twists around. I mean, we could desolder it, but there are so many pins underneath there, so I think no. I'll leave it on. So what I will do now is I just got to get the power connector off the lid and plug it into here so we can switch it on and off. I could short it underneath, and when I plug it in, there's a switch on the power unit over the back there, so I could switch it on and off, but that means I'm reaching over everything, so I'd rather have the switch up the front here. So I'll just pull that off the lid and we'll be back to you. Okay, I'm back. So I got the switch out of the lid, so I'll put that back on here. And that just means it's easier for me to turn on and off. The leads are all insulated anyway, so that's all good. So what we need to do is try and find out where these voltages are going wrong. So I'll plug this in, turn it on over the back, and then come back and we'll take some measurements off this and try and see what's going wrong where. Okay guys, I brought up the schematic for the power supply that I have, and looking at it, I think we'll just check what the power out is on here. So I've got that turned on, so we'll chuck that into DC volts. And what we'll do is we'll turn it on and we should get the red power light. Yep, which we do. So the red light's on, telling us that there's power on. So now if we take an earth, which will be black, I might have to change my tips for this, and we go to a yellow, should be 12 volts. So we're only getting 3.3. So there's something going on in this power supply why we're only getting a low voltage. There's not a high voltage coming out of this for some reason, higher voltages coming out of this. That should be 12, minus 12, 5 volts, and then you have your protection, which is your switch which goes to the MSX on-off power switch. So yeah, I think there's definitely something going on with this thing. So that's your 5 volts, it's at 1.32. So looking at the schematics, the voltages should all be sitting there. It's at the other end when you turn the power on that it allows it to go through into the PC. So there is something definitely going wrong with this circuit. So I think we need to check the transistors, maybe the diodes. Yeah, I think we just need to have a look through this and find out what's going on with it. Alright, so I'll power this off and let it discharge, and then we'll turn it over and have a look and see what's going on. Alright guys, my printer's a little slow, so what I'm going to do is, while that's deciding when it wants to print, I've decided I'm going to take this big heavy connector off. It is a pain for me, so what I'm going to do, I've just got my desoldering gun turned on to heat up. I'm going to flow a little bit of hot air across here first, and then I'll use my desoldering gun, and you'll actually see how easy it is to desolder stuff with a hot air gun and a desoldering station. And then we have it, it's out. What a nasty little thing that is. They're not actually a normal pin that goes through. It's like a loop of wire. I'll do you a little drawing up and show you what it looks like. Well, hang on, I might see if I can get it on the camera if it'll focus. No, I don't think it's going to. But they're a nasty little piece of wire. I will show you on a piece of paper what they look like. Hang on a sec. Okay, so what they actually are is they're a wire that comes up like that and is part of the plug that the wire is on. Each of them is like that. It goes through the hole. So that's why I was having to pry it out. I thought this should just, they were all moving. And I was saying this should just fall out. But it wouldn't. And I was sort of prying it, one end sort of dropped a little bit, and then the other would pry and pry. And until I got it out and I looked at it, and that's what it is. And I think, easy for them to solder in. What a nasty piece of work to try and get out. But it's out. So now I can move it out of the way, and I know how to put it back on because the board actually has the voltages written on the top of the board for me, so I know what I'm doing. So I'll move that out of the way and get it out of my way now, and we'll have a look and see what we can find out about these voltages, eh? Okay, so I've got my schematic here which tells me the board, and you have to be careful. There's about 4 different boards. There's about 4 different boards for these things. So it's quite good that on the silk screen copy they have in the manual, they have the board model numbers, and so this is a model I. So yeah, there's quite a few. There's an M and an S and another one I can't remember, a K I think it is. So this is our board. So there's obviously slight differences over time, but I'm not sure what. But anyway, so what we will do is we will work backwards to try and find out where the problem is with our voltage. So we'll start with the 5 bolts and we'll work our way backwards over the schematic and try and find out where our issue with the 5 bolts is. Right guys, I wasn't happy with the, I just started probing it again. I wasn't happy with the readings, kept fluctuating all the time. So what I'm going to do is I'm going to give it a really good clean with some isopropyl, and just maybe flux all over the board and that, and it's actually quite old. It's actually quite old and yellow. So what I do for heavy cleaning, I buy, you get these at your $2 shop as well, and they usually have a fibre, a brass, and I think a stainless or a steel tip on them. And the plastic and fibre ones are good because they're nice and hard. You can get in there and give it a good scrub without worrying about doing any damage to the board. So I just want to get in there and give this a really good clean. Alright. Right, so that was what came off it, and it was really black on the bottom when I first started, and it's actually come up really good now. So I think we just put some power back onto it, and let's see if we get any proper voltage readings off the shell. Okay, so what I'm going to do, I'll turn it on and I'll show you the voltages I'm getting. So I've got this down here, I don't know if you can quite see it. It just tells me where they are. It's frame ground, 5 volts, ground. That goes to the protector switch, minus 12 volt and plus 12 volt. And I'll show you on here what I get. That's 5 volts. That's minus 12. And that's plus 12. If not, as I was saying, we may have to put the jumper wire across that protection piece to make it turn on. Okay guys, so what I'm going to do is I'm pulling these big capacitors out. I just want to double check that these are okay. They could have gone faulty again. They're 100 UF at 220 volts, 200 volts. So to get any of this heavy stuff out, the best way to do it is to get your hot air, heat up the planes where it's got to come out. Put your desoldering gun on it. And that should be it. Yep. And that'll pop out. And just taking note that the positive is actually going that way. So what I'll do is I'll actually put a mark on that side so I know which side is negative. So that they seem to read all right. So yeah, it's telling us down here they should be on about 0.8. So that's at 0.1. So that's really, really good. So we'll put that back up there, so we know those caps are fine. So what we can do is we can pop those back in, and actually taking a little bit of a closer look at that board, there's actually a small plus on both sides there, so I didn't actually have to put that on there, but it's always good to note where your positive and negative are for your caps on a board before you take them out, because the silk screen on the board could be wrong, and if it was working when they were in there and you put them the other way around, it's not going to be working afterwards. I'll just give them this a bit of a clean. The other thing I had was that I did some research online when this presented a problem once with us before on the last video, and they said there was a glue they used around some resistors and some capacitors, and that it went conductive, and so I've pulled all that off. So that's what all this stuff is over here, this brown stuff. So I went through and I pulled all that off, and to get that out just in case that may be causing us an issue. They used it all down the side of the chokes and the filters and that sort of stuff as well. So taking all that off, cleaned it up as good as I can, took it off the side of these large capacitors as well. So that's done. So I think, well, that's not those, so we'll put them back in. I don't think it'll be these resistors. The only thing I can think of is it could be one of the transistors around here, or it could be an issue with the transformer maybe. But we'll put them in and we'll see how we go. Okay, so I've swapped the two coils over. That was the one that was getting hot from here, so I've changed those two around. So we'll see what happens when we turn it on. And yeah, it's not getting hot and it's not squealing like it was before. So what I'll do is I'll just flip it over and see if we can take some voltages from it and see what happens there. Okay, so I've got a wire jumper across those two, so now I'll turn it on and we'll see what we have. It's not squealing, which is a good sign. So that's our 12 volts. That's our minus 12, and that's our 5 volts. So how do you think that looks okay? It looks okay to me. So maybe it was just that filter coil that had an issue on the rail. Okay guys, so I've been playing around with this MSX again, and been talking to a chap on one of the MSX forums who's a really nice guy. He gave me some pointers on what to check and to look at, and we did a test with seeing if there was a picture signal on the outputs going to the video board, because we're getting sound but we're not getting video. So we can put a cartridge in and all that sort of stuff works, and we know the machine is working, just no display. So I checked the three output colors that get combined on the video board to see if there's anything there, and all I'm getting is some wavy static on the monitor. So we sort of decided that if we had a picture, even though it be black and white, it's probably going to be the LVA 510 combiner that is on the video board that had an issue, so it wasn't doing the signals properly and putting them out on the video. But because there is no video picture on the cable going to that board, The option would there have been it may be the VDP that's fallen over, and if you have an early MSX like these ones, they are susceptible to dying, and that's just through heat, through age, or a spike or something like that. They weren't a very tolerant chip to fluctuations in heat. So I'm getting ready. I'm going to desolder this one, and here I will show you how I desolder these sort of chips in using the hot air and the desoldering gun. So I told you I'd show you how to do this, and this is what I'm going to show you now. So give me a few secs. I've just got to grab a few little bits and pieces, and then we'll get on to it. I won't talk to you while I'm doing this, so I'll put the mic out of the way, and you can just watch me from the overhead camera, and I'll just leave the face camera on, so you might see me muttering to myself at times. Alright, so I'll do this and then we'll get on to it, eh? Right, hopefully this is not going to be too grainy for you guys to see. I've zoomed it in about as much as I'm sort of comfortable with at this stage, but I'm not too sure how well you can see that. But we'll give it a go and see how we go from here. Okay, and so there we have it. So I was just using the hot air there to release sometimes on the top side the solder will flow through and there'll be a little bit attaching it to the top. So what I did there, I was just heating it from below, and it was just detaching any solder that was on these top holes on these pins, and I was just using this underneath it to gently pry it just to make it come loose, and as soon as the two ends came loose, the whole thing came up really easy. Alright, so that's how I desolder these sort of chips, and that's not really any warmer than it gets when it's normally running. So you leave those to cool naturally, and what you can do is then go along, clean up any of these holes if they need it. Most of these look fine, same as the underneath. You saw here where this capacitor was. This is that horrible bloody glue that they use that can become conductive if you're not careful. Now I'm not saying that it may have played a role in what's gone wrong with this, and that it was touching a couple of the legs down here. So whether that caused an issue, I don't know. So now I'll just go to pop into the back bedroom where I've got all my spare sockets and stuff like that, and get a socket out for these. Now, hi guys, sorry, I might have put you a little bit wrong there. Just re-looking at them, they are a standard pitch for the sockets. They're not the smaller ones. It must have been the 9958 or 38 that I was thinking of that has a finer pitch on it. So yeah, these ones seem to have standard pitch, so yeah, standard socket will go fine. When you put your socket in, you look at it and you look for the notch at the end, and this one has a notch. That points to where pin 1 and pin 40 are on the chip, and the board will have the notch in it as well. So you put your socket that way, so that when you put your chip in, your chip will have a notch or a dot by pin 1. It goes that way as well. Don't put them in back to front, you'll kill the chip and maybe the board. So anyway, we will pop our socket in. There is this annoying connector that I've soldered onto the board here, so it might take a little bit of massaging to get this thing down gently to get it to go in. One of the pins is pushed up, so I'll just gently push that down. So, and that's the nice thing with this tool, because it's got that very sharp pointed flat blade on it. You can put it into the IC socket and push the pin through if it just gently gets knocked out. So that's what I say. If you're on AliExpress, look for the dentistry tools, and you'll find that they come in a little black kit. And there's this one, there's a straight one, and then there's some flat type scraper things, and maybe I think a mirror, something like that. But worthwhile getting, very, very handy. So that's in there, so that's all good. So what we'll do is we'll go about soldering it. So you don't want to listen to me prattle on, so what I will do is I will mute the mic and put something on and get on with soldering. Just a little bit of information here. When I put sockets in, I generally tag one at each corner. So then what I can do is if they don't sit flush to the board, I can then heat up the corners and push them down to make sure they're sitting flush in the board. So that's just a little bit of a tip there. You probably knew it, but I thought I will mention it anyway so you guys can know that I'm doing that. Sorry about that, guys. Yeah, it was actually pin 8 on this side, not 7. So yeah, so it's a ground from here to pin 8 on that side. So I just had to double check that because I don't want to be putting it on the wrong pin. So that's all soldered in now. So I suppose the next thing we do, give it a bit of a clean, put it back together, and I have some new ones of these that I ordered in. They are here now. So if this is faulty, we'll put a new one in and see what we get out of it. Let's get on with it. Okay, that looks all clean. I just had to put on my my 3x glasses just to check everything to make sure there was no bridges or anything. I did notice there's a couple of little splatters of solder down here, but they were sitting on solder masks, so they're fine, so they won't cause an issue. I just sort of picked those off and I'll brush those off shortly. So now I think we should flip it over, plug a chip in and see how we go. Okay, sorry about that. I just zoomed you out so you could actually see a bit more of what I'm doing. So just plugging everything in, I'll put the video board in and hope that it's actually going to work with the new processor. And so these are the new processors I just got in. So we'll pop one of these out and put it into its socket. And what you guys can do is, on a later video, I'll do one on the tools I use and the basic tools I use. You can get files for printing things like this, and you might look at it and think, now what the is that? This is a small version. There's two. There's a small and a big one. What they're for is when you have ICs, you put them in between here, squeeze the legs, and it straightens them all so they'll go into a socket. So this is for the smaller ones like the RAM and the small LS chips and that. There is a bigger one which I haven't got my hands on at the moment, but I will get it and show you. And yeah, and they just go on there and you just squeeze them together and they straighten up all the legs for you. It's really good for if you've got a few bent pins as well on some of your ICs. You put them inside here and just gently squeeze them and straighten them up. But I'll share that with you in a later video. And I've got quite a few of these kicking around. I printed them up for one of our computer get-togethers that we have once a year that I actually... the last three I've organised for our Facebook group, and we do this, and if they contribute to paying for the hiring of the hall and that, and they get some little goodies in their bags. And I think there was this and one for bending the legs on your resistors and capacitors and stuff to get in the right spacing. So there's stuff like that as well. So, but I'll link all that stuff for you guys in a later video when I go to talk about tools and things like that. For now, we're just going to have to use a flat surface to square the legs up. Alright, so we'll get on with that. And so that's in there, that's in nice now, so that's sitting in there fine. And it's oriented the right way with the notch at the end, but it should be. So, the only thing to do now is make sure everything is safe and nothing is going to short. Plug a video lead in, and I'll fire up the monitor and see how it goes. Now, if we're really lucky and we get a picture out of it, I'll spin the camera around and you guys can see that. Ready? Here we go. And that's, I have that cartridge in. And yes, sorry guys, no, that didn't work. So it may not have been the 9929 that was faulty. It may still be in the video circuit. It could be that 510. That's a bit sad. Anyway, we will carry on and try something else. Until next time, ciao.